If you've ever watched a treadmill run and thought, I know it works, but I'm not totally sure what it's doing, you're not alone. In this episode of Tool Tuesday, I'm going to explain what threadmilling actually is, how it physically creates a thread, and how it's different from tapping, without getting too theoretical or academic. By the end, you should be able to picture exactly what's happening inside a hole when a threadmill runs. Most people encounter threadmilling after tapping causes a problem. Broken taps, inconsistent threads, and materials that don't behave. So they hear, try a threadmill, but they don't understand how it differs from a tap. That's usually where the confusion starts, because threadmilling isn't tapping at all. A tap forms a thread by pushing its full shape through the hole in one synchronized motion. A threadmill cuts the thread profile gradually by moving in a controlled path. A threadmill is always smaller than the hole it's cutting. It spins on its own axis, like an end mill. At the same time, it moves in a circular orbit around the center of the hole. While it's doing that, it also moves in Z. One full orbit around the hole, combined with one controlled move in Z, creates one pitch of thread. That motion, spinning, orbiting, and moving vertically at the same time, is the process. You're not forcing a shape through the material, you're machining the thread into existence. Because of that, the CNC controls the thread, not just the tool geometry. The size of the thread is controlled by the diameter of the circular path you program. That's why one threadmill lets you cut different fit classes or a different range of pitch diameters. In other words, threadmilling lets you dial in fit without changing tools. It also explains why threadmilling only works on CNC machines. You need coordinated motion in X, Y, and Z at the same time. Threadmilling can be used for internal threads and external threads as well. That motion stays the same, only the direction and feet adjustments change. And that's the key idea to hold on to. Threadmilling isn't a specialty trick. It's a milling process that happens to create threads. Once you see it that way, a lot of decisions start to make more sense. Tool choice, feed strategy, physical setup requirements, and so on. But what happens when you think you've dialed in all of those variables, but your threadmill process still isn't working? In this next episode, we'll break down why threadmilling failures aren't random at all, and how almost every problem traces back to just 3 causes. Subscribe so you don't miss it. If you've ever had a threadmill snap, chatter, or refuse to gauge, that episode will help you figure out where to start looking.